Hey, I wanted to shoot a video out to you guys really quick. I've had a few students ask a few more questions about the z-score calculation and percentiles, and I wanted to make sure that I covered that. I don't believe I actually talked about percentiles on accident. Sorry about that. But I'll show you how that works with the z-table and the z-score and all that other stuff. So first off, again, just a really quick reminder of what the z-score formula is, all right, the different parts. First, we've got the number we are investigating. So, for instance, if they say the mean of data is 100 and the standard deviation is 15, and they ask, well, where is 72 on that particular chart? 72 would be your X value right here. Okay, so this is the number that you're kind of like looking up. All right. Second part, of course, is the mean. This is the Greek symbol for mean here. Um, so, whatever number you had in the very middle of your data, or if they just give you the mean, that goes there. And then the final part that we have here is the standard deviation. So these are the three numbers that generally you'll be given. Occasionally, when they ask a percentile question, this will be a number that you won't know. They're saying, hey, what would be the score that would be at a certain percentile? So this would be the number that we would be looking up. So let's see a couple of the other things that we need here. Well, we need a z-table. A couple of quick little reminders about the z-table. One, there's 2 pages to it. You can't just get around with one, but there's 2 pages to it. So the first page is a negative, all right? And then all the negative values, by the way, would be on the left side of the z-table. That's because if you notice, these numbers here are percentages. This is 0.0003. This is actually 0.03%, because if we took this decimal and moved it 2 places to the right, it would be 0.03%. In other words, if you had a z-score of negative 3.4, that means only 0.03% of the data would be to the left of that value. And then as you can see, as these numbers increase, it gets really close to 50%. So for instance, a z-score of 0, exactly 0, well, that's where the mean is. That means 50% of the data is to the left. Here we got 49.6% of the data, 49.2% of the data at, this is a z-score of negative 0.00, negative 0.01, negative 0.02, and so on. That's these values that we have at the very top, So again, if you wanted to look up a z-score of negative 2.96, well, here's negative 2.9, and over here's a 6. So when you line that up, that means if you move that decimal 2 places to the right, 1, 2, that means 0.15% of the data would be to the left of that value. There is also a positive side, and notice the positive side starts at 50% and then works its way up to 100% of the data, or nearly 100% of the data, 0.9998. That's 99.98% of the data. So again, we need our z-table, and we're going to put all this together. A reminder again that z-table data only finds left side data. So if they ask if something's greater, you're going to have to convert it. All right. And if they ask between questions, there's a way that you have to deal with that too. So with all that information and this table, or this z normally distributed bell curve right here, we're going to go ahead and just use this data. Now, if I told you that the mean of a set of data is 600 and its standard deviation is 50, the way you would put that on this curve is just to drop it in just like this right here. Okay, the 600 would be right here in the very center. That's the mean. And then you would count up by 50s moving to the right, and you would count down by 50s moving to the left. And if I asked you how much data is below a 600, you would say, well, that's 50% of the data. This is half of the data on this side. If I asked you how much data is below 650, we don't need a z-table for that. What we need is empirical rule. So we know that this, little section from, well, let's say from here all the way to the left, that's 50% of the data. Plus, we know that this section in here contains 34% of the data, because we know that from here to here is 68% of the data, and these are symmetric, so this would be half of that, 34. So if we added 50 plus 34, we'd say, hey, 84% of the data is below 650, all right? So we don't need this calculation, this z-score calculation for any numbers that are directly on these lines. What we do need is we need this for in between. So our first z-score calculation, just to make sure you guys know how to do this, let's say we wanted to find out the percentage of the scores that are lower than, let's say, 625. Now 625 would be right in here, okay? Right, here's 600 and here's 650, so 625 would be right here. So all we would do is we would take our 625 and it would go right here. This would still be 650, and this would be 50. And this here just comes from our data over here. So 625 minus, 600 is what this would be, the very middle. 625 minus 600 over 50. So 625 minus 600 is, of course, 25. And that's over 50. And I hope everybody sees that that's basically 1/2. So that would be 0.5, right? So we need to look up this value on our z table. So we go to our z table. 0.5 is on the positive, so we're going to go down to the positive one. And 0.5 is right here. And this is, in this first column, is 0.500. So we want this right here, 0.6915. Right there. That's the number we want. So when we go back to this, we can say that 0.6915 is the percentage of the data that's to the left, again, of, let me bring these values back up. Okay, so we're looking at 625 being right here. So to the left of this line right here, all of this data out here is 69.15% of the data. Now, if they ask for right side data, we would just take this away from 100 or 1, however you want to do that, 1.0000 minus this, or 100 minus this, all right? We would be talking about, looks like 30.85% of the data. So that's how much data is on this side, all right? So that's left side, right side. Again, this initial calculation always finds left side data. You have to convert it to right side data by taking it away from 100% if you want to. So that's how you do left side, right side. The whole in between, really quickly, just to show you that. So let's say we wanted to find out what percentage of scores are between, let's say, 640 to, let's say, 730. What percentage of scores are between 640 and 730? So 640 is about right here, and 730 would be about right here. So we want to find out how much data is between these two right here. So we're talking about in here, how much data, okay? What we have to do is we have to do this z-score calculation 2 times, all right? Once for each of these values. So the first one would look like this, 640 minus 600 over 50. And the second one would look like this one, 730 minus 600 over 50. And we're going to get these two values. This is 40 over 50, which we know is 4/5. And this is 130 over 50, which we know is 13/5, which again is not that big of a deal because we're just going to throw this into a calculator. So 4 divided by 5 is 0.8. And 13 divided by 5 is 2.6. So what we're going to do is we're going to look up these two z-scores, all right, 0.8 and 2.6. So down to the positive one again, oops, 0.8. 0.8 is right here, 0.7881, right? And 2.6 is right here, 99.9953, all right? So 0.7881 and 0.9953. 7881.9953. Let me just double check those numbers, make sure I got the right ones. Yep, okay. So if what we're saying here is that from this part over, 99.53% of the data is below that value, and 78.81% of the data is from this part over. Now, what do we not want? We don't want this data. We just counted this data twice, okay? So what we're going to do is we're going to take this value here and this value here and subtract them, all right? So if we take 0.9953, oops, boy, that's way too many. 0.995, my calculator is freaking out, I don't know why. 0.9953, subtract 0.7881. And that tells us 20.72% of the data, 0.2072, 20.72% of the data is found in this stretch right here. All right, from here over to here is 20.72% of the data. All right, so there's really no other types of problems you can do with the z-score calculation as far as you can do left problems, you can do right problems, you can do between problems. Now there is one other type of problem that I did talk about that doesn't really use this number. It's when we're looking for this number. That's a percentile. So I wanted to show you an example of some percentile stuff. Let me get rid of all this fun stuff here. So percentiles. Here is a percentile chart for heights of Americans, I think age up to 20 or something like that. So let's say you were a guy and you were, I don't know, 5'10", and you wanted to find out what percentile range you were in for 5'10". Well, as long as you knew the mean and the standard deviation, you could do that. Let me give you an example of what a percentile is. At 6 foot, for a male height, at 6 foot 0.64 inches, so a little bit over 6 foot tall, that places you in the 90th percentile. What that means is that 90% of people are shorter than you. All right, 90% of males are shorter than you if you are this tall. If you are a 5'7" inch tall male, approximately, 25% of people are shorter than you. Conversely, that means 75% of males are taller than you. For a female, if you are 5 foot flat tall, that means you are taller than 10% of the population, and 90% of the population of females are taller than you. So that's how percentiles work. So if we go back to this data that we had here, and let's say I wanted to find out what would be the percentile, what would be the score that would put, let's say, 30% of this data below you, all right? So I'm asking what number on here, what actual number between 450 to 750 places somebody in the 30th percentile. Okay, now what we're going to do is we are going to go to our z-table. All right, so we go to our z-table, and what we want to find here is we want to find the number over here that's closest to 30%. Now we do know, just by looking at this right here, remember this line that goes straight down the middle, that puts 50% of the data on this side. Now, if the 30th percentile line would have to be somewhere over here. It's got to be somewhere over here because it's only got 30% of the data to its left. All right? It only puts 30% of the data to the left. So we know we're going to be looking at the negative, because all the z-scores on this side are negative and all the z-scores on this side are positive. So we know we're going to be looking at the negative table. So we want to find on the negative table the number over here that's closest to 30%. Now remember, 30% written as a decimal is 0.3 basically 0.3, but we can add 4 zeros on there. So we want to find the number that's closest to 0.3000. So we go down the list, not 0.0300. So we're not going to be looking like here. We're not going to be looking at this one, 0.3000. So as we go down the list, we find that the closest value to 0.300 is this one right here. Okay, that is only, let's see, I guess this is tenths, hundredths, thousandths, 10,000ths. So this is only 15 thousandths away from 0.3000, while this is 19 thousandths away, or I'm sorry, 19 10,000ths away. So what number is this? Well, here's a negative 0.5, and then the decimal that goes with that is 2. Okay, so when you put that together, that's a negative 0.52. So what we need is we need to take that number, and we're going to throw that into our z-score formula, except remember, guys, that is a z-score. So that's going to go here, all right? So we got negative 0.52 equals, and this time we don't know the x. Remember, we're looking for this number. We do know the 600, and we do know the 50. And we're just going to do some algebra skills in order to finish this particular thing off, okay? So, so what would we do to get our x by itself? Well, the first thing we got to do is we got to get rid of this 50 that's in the denominator right here. So remember, fraction is division. I'm going to change colors here. So we're going to multiply both sides by 50 to counteract that. So these would cancel. All right. So get our calculator out. And we've got 0.52 negative times 50. That gives us negative 26 equals x minus 600, because that's all that's left over here. So then we're going to have to add 600. All right. And x equals negative 26 plus 600. And we get 574. So in other words, the number 574, well, this would be 575 right here. So right about here. The number 574, which is right about here, is the 30th percentile. So in other words, 30% of the data is over here. Okay? So this is 574. So that's how you find percentiles on these z-scores. You just basically look up the percent in the z table, drop that corresponding value in here, and then just do a quick little algebra. Okay? All right, guys. Hope this is helpful to you. Thank you.